Hello everyone, Chapter 7 Geometrical Optic consists of reflection at spherical surface, refraction at spherical surface, and thin lenses. We have three equations under subtopic 7.1. F equals to 2r, magnification equals to negative v over u, which also equals to hi over ho, and the thin lens equation, 1 over f equals to 1 over u plus 1 over v. Next, we have two equations under 7.2. Refractive index n equals to speed of light c over the image distance v, and the other one is spherical surface equation. And 1 over u plus n2 over v equals to n2 minus n1 over r. The 7.3, we're going to see again 1 over f equals to 1 over u plus 1 over v. Then we have this lens maker's equation, 1 over f equals to n material over n medium minus 1 times 1 over r1 minus 1 over r2. And the third equation is the magnification. The amazing thing about magnification, M can give us all the characteristics of an image just by looking at its sign and the magnitude. Let's take a look at this sign. If the sign is positive, it means that the image is virtual and upright. If the sign is negative, it means that the image is real and inverted. Now let's say the meaning behind its magnitude. If the magnitude is bigger than 1, it means that the image is magnified. If the magnitude is 1, it means that the image is the same size as the object. But if the magnitude is less than 1, it means that the image is diminished. Now let's see some example. Negative 3. Negative means it is real and inverted, and since 3 is bigger than 1, the image is magnified. Positive 0.5. Positive means virtual and upright. Since 0.5 is less than 1, it is diminished. Negative 1. Negative is real and inverted, and 1 is same size as the object. Negative 2.5. Real, inverted, and magnified. Positive 1. Virtual, upright, and same size. And lastly, negative 0.72 is real, inverted, and diminished. Now let's do some exercise. You may pause the video to read the question. We have focal length positive 10 centimeters. The u is 25 centimeters. We're going to find v. We're going to substitute all the values in the spherical mirrors equation, and your v is 16.6 centimeters. Since the question is asking us to describe the image, we're going to use magnification. This time, we're going to use m equals to negative v over u, substitute all the values, and the magnification is negative 0.66. Negative is real and inverted, and 0.66 is diminished. We're going to use the same method as in A for B. Now that we get the image distance V equals to negative 10 centimeters, we're going to put it back into the magnification equation so that we can get all the characteristics of the image. Positive 2 means it is virtual, upright, and magnified. Let's look at spherical mirrors. We have concave mirrors and convex mirrors. Concave mirrors used to magnify things. Dentists use it to magnify cavity, and we use this concave mirror to magnify our face when we put on makeup. And convex mirrors normally used to get wider view. They're normally located at corner of shops or to reduce blind spot on a side mirror. Now let's take a look at concave mirror characteristics of image when we put the object at different location. We put the object farther than the radius of the curvature. The image is real, inverted, and diminished. If we put the object exactly at the center of the curvature, then we're going to see the image is real, inverted, and the same size as the object. If you put the object in between the focal length and the center of the curvature, then the image that we're going to get is real, inverted, and magnified. Now what happens if we put the object exactly on the focal point? Then there is no visible image. We describe it as infinity. Next, if we put the object less than the focal length, then the image is virtual, upright, and magnified. And this is where we apply the makeup mirror. Now let's go to convex mirror. Regardless where you put the object, the image is always virtual, upright, and diminished. Here are some important sign notations for mirrors. Exercise time. So in the question, distance between the image and the object is 20.5 centimeters. So u plus v equals to 20.5 centimeters. Means that v equals to 20.5 minus u. Height of the image is a quarter than the height of the object. Where should we put the mirror to the object? Actually, the question is asking for u. So let's find the magnification first. This helps us to identify the characteristics of the image. Positive 0.25. It means that this image is virtual, diminished, and upright. We have two equations for magnification. We're going to use the other one, which is m equals to negative v over u. Put it back into, and wow, 27.3 centimeters? This is not right. There's no way that the object distance is bigger than the object distance plus the image distance altogether. Oh, it is because it's virtual. In order for us to get the virtual image, the v must be negative. Now let's try this one more time. Yes, 6.4 centimeters is more logical answer. Lesson B is asking for the radius of the curvature. Here, I'm getting the V first. because I want to put the value of u and the v into the thin lens equation. Ooh, remember, because the image is virtual, we have to put in the negative sign. And since we know f equals to r over 2, we substitute everything like this. And look, the r is negative. And when we refer to the sign notation table, it means that this mirror is a convex mirror. That's all, everyone. Thank you.